Section 9.1 is going to discuss radicals, square roots, and higher power roots, and probably go into a little bit more detail than you've seen before. Let's start with kind of a friendly, simple example. Problem number 24, square root of 49. Now, I don't think we need to take out our calculators to calculate this one. I'm sure that most of us are pretty familiar with it. We're looking for a number that we can square to get 49. 7. Good. But what if somebody said the square root of 49 is negative 7? Does that work? It kind of works. But this is, I mean, if you square negative 7, you do get 49. But to avoid confusion, what we'll do is if I want the negative root, I'll put a negative out front. If I want the positive root, I'll just leave it here. And sometimes I'll get greedy and I want both. I'll put the plus or minus here. And then you give me plus or minus 7, so you can get both. So in short, I'll ask for what I want. If I want the positive root, negative root, or both. So let's play around with these. Sometimes, more often than I would expect, this one doesn't get simplified. People just leave it like that, as if it doesn't simplify. Maybe you can do better, though. How would you simplify negative to the square root of 1? Go ahead. A little bit louder, Mitchell. Negative 1. Good. Square root of 1 is 1. We're taking the negative root. So, negative 1. Let's look at some more problems, like problem number 28. Square root of 4 over 25. Now, for a problem like this, for division or multiplication, you can break things up. So I'm going to break it up as a square root of 4 over the square root of 25, and then simplify that. What would the square root of 4 over 25 turn into? 2/5. Good, thanks. 2 over 5. Now some of these are going to require a calculator. So let's start with problem number 36. Square root of 340. And 36, they want you to round to the nearest fourth decimal place. So at least on your graphing calculators, to get the square root key, you have to hit the second key, then the x squared key, because right above the x squared key, you'll see the square root. And that's going to give you to the square root. So square root of 340, I'm getting 18.43908, etc. On an exam, if I asked you to round this to the nearest 10,000th, the nearest 10,000th is the fourth decimal digit. So that's right here. What would this round to? Yeah, 18.4391. If I take the time to ask you to round a specific digit, then there's 1 point of credit for rounding to that appropriate digit. So don't lose that point. Be a little bit careful in rounding here. Now, had this been, say, like a 2 or a 3, when I rounded it, would I have to write the 0 if I'm rounding to the nearest 10,000th place? Yes, because without it, it looks like you're rounding to the nearest 1,000th, not the nearest 10,000th. So it makes a difference. If I'm asking you to round to the fourth decimal place, there should be something there. Whether or not it's 0 doesn't matter. Let's try another one. Problem number 38. Square root of 0.0063. So same kind of problem as the last one. We're on a round to the nearest 10,000th. Something strange happens when you take the square root of a number between 0 and 1. Can you see what it is? What happened to our number? Yeah, it got bigger. That's all right. That's going to happen to numbers between 0 and 1 when you take their square root. It's going to get bigger. 0.079 what? 4 or 3? 4. Good. Again, be careful, round up when you're doing these things. 10,000th is my default for a lot of problems, but you know, some problems, like there's a problem I remember later in the book that asks you to calculate the estimated time of death. Round to the nearest tenth would be fine. Even more later, when we start dealing with radioactive decay, rounding to the nearest year or to the nearest whole number would be fine. So it's going to depend on the problem. Okay, so let's keep going with some square root stuff. And I kind of want to give you a little bit of a heads up before we do the next problem. And I'll even give this section kind of a title: square root of x squared. I want us to think about what happens when you square or take the square root of something squared. Well, x is almost right, but let's take a look at something. Suppose I take the square root of 5 squared. 5 squared, of course, is 25. Square root of 25 is 5. Okay, good. But what if I started out with negative 5 and squared it? What do I get when I square negative 5? 25. And the square root of that is 5. But if I start out with negative 5, I end up with positive 5. So this isn't quite right. It's not complete. We have to assure that this number is positive, because regardless if I start out with something positive or negative, I end up with something positive. So how can I guarantee that this expression is positive? Absolute value. Good. So some of you thought I was signaling touchdown. I was really trying to throw that into your mind. This is absolute value. So in order to guarantee that that's positive, we need to use the absolute value. So let's do a couple practice problems with that, starting with problem number 40. Square root of 64. I'm going to write x squared. The book writes t squared. I think I've discussed my preference for x. Doesn't look like a plus sign so much. What I would suggest is that we break this up. Now you can break up multiplication and division. You can't break up addition and subtraction. So I can break this up as the square root of 64 times the square root of x squared. What would that give me? Good. 8 times the absolute value of x. And I appreciate very much that you got in that absolute value. That's the point of this right here, is that you need the absolute value to guarantee that this expression is positive. It's just a happenstance of working with the square root of x squared. Let's try another one. Yeah, please. It's, you know what, it's a great question, and I'll build to that. It's going to be a little bit more general when you're going to need to use the absolute value. So, for instance, we don't need to use it when we have cubes, but we will need it when we have squares. But we'll get there. So to continue, let's do problem number 48, and I'm going to help you out a little bit on 48. It's the square root of b squared minus 14b plus 49. Here's my help. This is going to factor. It's going to factor is b minus 7 times b minus 7. But on your most recent exam, if you gave me b minus 7 times b minus 7, you'd lose a point. When we went over this in class, I said I want you to write that a little different. How do I want that written? Yeah, b minus 7 squared. And that makes all the difference in the world for a problem like this, because that last expression is something we can simplify. How do we simplify that last expression? Appreciate the effort. Bingo. These cancel each other out. Square root and the squared cancel each other out, but we have to use the absolute value. The absolute value of b minus 7. Now, one last thing here. I know it's tempting, but with the subtraction, just like with square roots, absolute values, you can't distribute this. You can't say that's the absolute value of b minus the absolute value of 7 or anything like that. It just doesn't work. Leave it as is. This is your final answer right there. It just doesn't simplify any further. So, are we okay with 48 there? Let me give you one to try. It's not one that's in the book. Square root of x squared minus 10x plus 25. See what you can do with that one. Just go ahead. Give you a hint, it's very much like problem number 48. Okay, Sidra, how does this factor underneath the radical? X minus 5 times x minus 5. Perfect. The absolute value of x minus 5. A lot of times what I get on a test is people trying to do this. Square root of x squared minus square root of 10x plus the square root of 25. And then they'll write x minus square root of 10x plus 5. Let me politely say you're making my job of grading very easy if you do that. It's just nowhere near the right answer. You can't simplify, you can't split up a radical across plus and minus. It only works for multiplication. So up here, when they're multiplied, I can break that up. If they're divided, I can break that up as well. But it doesn't work for addition or subtraction. Can't break that up. All right. Thanks, Sidra. Let's take a quick look at some of the graphs. And let me discuss a graph of y equals the square root of x first. And then maybe we'll look at a couple more related graphs. Actually, just as far as just figuring out what the shifts are going to be. So, graph y equals the square root of x. And I'm going to take kind of a shortcut in hinting at what this graph is going to look like. We'll look at it on Desmos. You can look at it on your graphing calculator. If I was to square both sides of this, I would get y squared equals x. Now, when you have something squared, you should start thinking of one shape in particular, and that shape is called a parabola. The difference with this parabola is that it's sideways. It would be facing to the right. So let me put up that parabola real quick. Y squared equals x. So that's kind of our graph, but really we have the graph of y equals the square root of x, which is just going to be the top part of that parabola. So there's your graph in blue, is the top half of a parabola that faces to the right. With that graph in mind, let's see if we can't figure out what the graph of a couple other things look like problem number 52. So let me come back to the projector here. Problem 52 asks us to look at the graph of y equals the square root of x plus 2 versus the graph of the square root of x. So what effect do you think the plus 2 is going to have on the graph? What kind of a shift? It's going to be up 2. So just based on the form of this, because that 2 is not under the radical, this is going to be shifted up by 2. Shifted up by 2. And we can see that if we were to take the time to graph it. So let me just get rid of this one and replace it with y equals the square root of x plus 2. So shifted up 2. What if I had that 2, for instance, underneath the radical? So what if I have, for example, y equals the square root of x plus 2? Now how would that be shifted compared to y equals the square root of x? Yes, this would be shifted to the left by 2. So again, let's see that. So y equals the square root of x plus 2. And there you go. Shifted to the left by 2. So it starts at negative 2 as opposed to 0. Nice. So these principles of shifting, apply to all the functions you can deal with. And it's just nice to be able to look at these and determine what their graphs are. Now we spent a little time working with domain in this course. The domain of the function is a set of values of x that you can put into the function. So let's think about the domain of the square root of x plus 2. And actually, I think there's a problem like this. Yeah, problem 56. We can take a look at this one. The domain is the values of x that I can put in here. My concern is that I want to make sure that x plus 2 is greater than or equal to what number? If I'm going to take the square root of something, that number has to be at least what? 0. You can't take the square root of a negative number. At least not getting a real number. So that means x has to be greater than or equal to negative 2. So that's the domain of this problem, is that x is greater than or equal to negative 2. You can see that when you look at the graph. The graph starts at negative 2. There's nothing to the left of the graph. It's just nothing. But to the right of 2 is where you're right of negative 2 is where you're going to find the graph. Let's take a look at problem number 56 and kind of repeat that a little bit and maybe go a little bit further. Great question. Square root of x. Let's think about problem 52 then as far as the domain is concerned. I need to make sure that what I put underneath the radical doesn't give me a negative number. So that would mean that x would have to be greater than or equal to what? 0. So if you look at the domain here just based on the algebra, that means x has to be greater than or equal to 0. When we look at the graph, we see the same thing. That the graph here starts at 0 and continues to the right. All right, so it's nice to see the same thing from the algebra and from the graph. Let's kind of repeat that to try and reinforce that with problem number 56. Problem 56 is y equals the square root of x plus 12. And I want you to figure out the domain of that graph. Dylan, what's the domain going to be, please? Good. So x is greater than or equal to negative 12. All right. Norman, how's this graph been shifted? If I was to compare this to a graph that I might be a little bit more familiar with, maybe the square root of x, how has this graph been shifted compared to this one? Good, to the left by 12. And let's see both of those things here. So let me just make this 12, kind of cheat, and zoom out a little bit. There's your graph. So it's been shifted to the left by 12. Now you can see from the graph that the domain corresponds to what we calculated, but what's much easier to do with the graph is figure out the range. What's the range here? The range is your y values. So what's the range? What's the smallest y value that you see for the graph? How far down does it get? What's the lowest that it gets? That's the x-coordinate. What about the y-coordinate? 0. How high do you think this graph goes? To infinity. So the domain was x is greater than or equal to negative 12. The range, so that's your domain. The range is y is greater than or equal to 0. That's where your y's start. Start at 0 and they go up from there. Let's move into cube roots, if there's no more comments or thoughts on domain and range here. You know, it'd be tough to do it otherwise. For this class, I'd recommend just looking at the graph. Now, if it's a graph of something that's obscure or complicated, I'd probably just give it to you and just put it on like an exam and say, here's the graph. Just look at it and tell me what the range is. Yeah. So I don't expect people to have graphing calculators. So it's a good question. The range in 52, let's look back. This is a good follow-up. So let's look back at 52, and let me shut these off, and let's just look at this graph right here. Why don't you see if you can't determine for yourself before we answer the question what the range is. Remember, the range is the y values from lowest to highest. So let's see. No. What's the lowest that the y values get? 2. Yeah, so greater than or equal to 2 would be your range for problem 52. So it starts at 2. Remember, you're looking at the y-coordinate, not the x-coordinate. Starts at 2 and goes all the way up to infinity. So 2 to infinity would be what you would write in interval notation for the range there. So the range is 2 with a bracket to infinity. You could also write it as 2 is less than or equal to y, or y is greater than or equal to 2, again for the range. All right, nice follow-up on that one. Let's move to cube roots. So when you're dealing with cube roots, you're looking for something that you can cube to get what's underneath a radical. Now, to let people know that you're dealing with a higher power root, like a cube root, we're going to write that number 3 as a little index of your radical. So the cube root of 8 would be problem number 72. Now you're looking for something that you can cube to get 8. Now on the left-hand side of the board, somebody extremely intelligent, athletic, and who's having a birthday today, wrote the first 10 perfect cubes for you. So thank you so much. So what do you cube to get 8? 2. And that's it. Although let's practice it on your calculators, because this is a different key than maybe what you're used to. And we want to be able to find that. So if you have a graphing calculator, then hit the math key. Does there look like a useful option down here? 4th option down. Now later when we do higher power roots, we're going to have to type in the number and then use the 5th option down. But for now, type in the 4th option, cube root of 8. For those of you with scientific calculators, let me walk around real quick and help you out. Actually, I don't see anyone with scientific calculators. Does anyone have a scientific calculator? No, that's a graphing calculator. You should be able to do yours the same way that we just did.
I had another question.
Yeah, okay.
For this one, like when you put like y equals the square root of x plus 12, like why is it giving an error? Like on his, on the one that you give out is doing it right. So I'm saying why wouldn't I graph it?
I have to see what error it's giving you. So if you want to,
Anytime I put x plus something or anything, it just says error.
you'd have to show me that, and I'll be able to help you out. I guarantee it.
Okay.
But as far as calculating roots are concerned, cube roots, are you able to get the cube root off your calculator? I mean, it's something that I will assume. So there's a good place to ask questions if you need them. Okay. Let's try some more with cube roots. One thing that's different about cube roots, and we can see that with problem number 74, is that you can take the cube root of a negative number. You can't do that with even-powered roots. With odd-powered roots, you can. So try taking the cube root of negative 27. Either do it on your calculator or just look at the board and figure it out from yourself. Yeah. Cube root of 27 is 3, but I have the cube root of negative 27, so I get negative 3. You can check that by taking negative 3 and raising it to the 3rd power. Negative 3 cubed is negative 27. So, cool. Let's try problem number 76. So the cube root of 125 over 64. Let's do this 2 different ways. The first way, again, takes advantage of the fact that I'm dividing these things. Can I break up a radical using division? Yes. Not with addition, not with subtraction, but I can with division. So it's the cube root of 125 over the cube root of 64. So Kennedy, can you see some numbers that help us out here? Cube root of 125? 5. Yes, happy Cinco de Mayo. Cool. How about the denominator? 4. Let's try it on our calculators. So to do it on our calculators, you hit the math key, then the 4th option down, the cube root. Now it kind of depends on your calculator. Some of you might get a left parenthesis there. If you do, great. If not, no big deal. Cube root of 125 divided by 64. Now I get 1.25, which is fine. But let's hit the math key one more time and then press enter twice. And we can turn that fraction, or turn that decimal into a fraction. So 5/4. So cool. It's nice. It matches exactly what we got by calculating it a little bit more directly. Bless you. Let's try problem number 70. Kind of an interesting one. It's not something that we've had in previous editions of this book. So they give us h of t is the cube root of 2.1t plus 11. And they ask you to calculate various values. And let's take the simpler of the two. Let's find h of 15. So that's part B. So h of 15. So that means we want the cube root of 2.1 times 15 plus 11. Now you can do two things. Either you can calculate this first and then take its cube root, or just take the cube root of that expression, whichever you see fit. I think I kind of want to know what that number is before I take its cube root. So I'm going to do 2.1 times 15 plus 11. Gives me 42.5. So then I want the cube root of 42.5. And like I often do, they ask you for these rounded to the nearest 10,000th. So let's see if we can't find that number rounded to the nearest 10,000th. So math, fourth option down, 42.5. I get 3.4897, 6, etc. Ooh, this is a good one. 4898, rounded to the nearest 10,000th. Okay, so good. You didn't necessarily need to find that number. Your calculator could have worked just as well with that expression. Cube root of 2.1 times 15 plus 11. Same thing. Are you comfortable finding these cube root numbers off your calculator? They're working okay for you, whatever calculator you have? We're going to do some more with cube roots. We're going to start expanding things a little bit and eventually working our way to answering Bailey's question from earlier. When do we have to use the absolute value in general? So the next one I want to look at would be problem number 80. Cube root of negative 512 x cubed. And because I'm multiplying, I'm going to take advantage of the properties of roots in general. That allows me to split that up across this multiplication. Now this first one is a number that you can get from your calculator or the left-hand side board. So either way works. Can anyone just figure it out by looking at the left-hand side board? What am I going to get when I take the cube root of negative 512? Negative 8. Good. Negative 8 because I can cube negative 8 to get negative 512. What do I cube to get that second term, that second radicand? Go ahead. X. Yeah, just X. Now let me help you out here, and we'll understand this more in section 9.2. But this number divides this number. And that's what's going to give you your answer to these types of problems. 3 divided by 3, or this 3 divided by this 3 gives me x to the first power. So that's kind of a shortcut. And let's take advantage of that shortcut as we do other problems like number 82. Now 82 as it's written in the book isn't really cool enough for me, so we're going to do problem number 82-ish. So I'm going to modify that a little bit. Let's write it as the cube root of negative 343. And let's do a to the 15th and b to the 21st power. So I'm changing the exponents here, but it's a much better problem. Well, maybe it helps to break this all up. Let's see if we can't simplify this. Mila, it's been a while since I picked on you. How would that simplify? She feels so nice to be remembered here. Go ahead. Perfect. So again, the cube root here you can get from the calculator, or in this special case, the left-hand side board. Here, divide 15 divided by 3 gives me 5. 21 divided by 3 gives me 7. So, yay. We don't have to restrict ourselves to just cube roots either. We can do higher power roots. Let's take a look at problem number 88. We've got the 6th root of 64. All right, so if you're looking at the left-hand side board, I quit after cubes. All right, so I mean, there's a lot of things I could put up there, but I quit after cubes. So we're going to need to figure this out in other ways. But we're still looking for something that we can multiply by itself to get 64. But how many times do I have to multiply it by itself to get 64? 6. So I need something to the 6th power gives me 64. Now, maybe you can guess at it, and maybe you'll get it. But let me show you how to find it on your calculators. Kind of hinted at this earlier, but let's do it now. First, you need to type in the number of the root, 6. And do that before you start looking for the nth root key. So type in the number 6, then go to the math key. Which option do I want this time? The 5th option. That should take and put that number up there as an index of your radical. 6 root of 64 is 2. How could I check that? If I looked at that and I'm like, you know, that just doesn't seem right. How could I check it? Yeah, 2 raised to the 6th power gives me 64. So, are you able to get the 6th root off your calculator? Okay. Colin? All right. Let's try another one. Problem number 90. Actually, we'll try 2. Problem number 90 is negative of the 4th root of 625. And problem number 92 is the 6th root of negative 729. So let's try 2 of them. Thank you. So we got a 2 there. How about problem number 90? What are you getting for problem number 90? 4th root of 625 should give you a 5. And I want the negative root there. So you got a negative 5.
So if the negative is just in front of the whole problem, it makes the answer just automatically negative.
Yes.
Is there ever gonna be a time where the 4 would be negative?
boy, that's an interesting question. What would this be if that was a -4? Uh, yeah, if you put it in as a -4, you might get like a .2 as an answer or something like that. Maybe. Is that what you got?
Oh, I don't. I fixed
Okay.
it after I noticed.
All right. Yeah. No, you're not. In this course, you're not going to have a negative here as the index of a radical. I have a hard time trying to think of exactly what that would mean to have a negative there. But no, we're not going to do that. How about problem number 92? What'd you get? Error. What'd you do wrong? Ah, very good. You can't take the even root of a negative number. It's just not a real number. Not a real number. Now in this class, we do something that, for reasons that defy logic, has not caught on with the wider math world. I turn this into an acronym. We call this NARN. So if you want to write NARN on your test for an extra credit point on these type problems, then go ahead. I always have to specify these type problems because I get people who write NARN next to every problem. It doesn't work. But if you run into someplace where you have something that's not a real number, great, write NARN.
I was going to ask you, explain again why.
Well, because you're trying to raise something to an even power to get a negative number. So the answer that you might think would be -3, because 3 to the third power, or 3 to the sixth power, gives you 729. But let's check it by multiplication. So -3 to the 6 would be the product of -3 6 times. So the 3's give me positive 729, but I've got an even number of negative signs. And those even number of negative signs give me a positive number back. So I get positive 729, not negative 729. That's why when you have an even root of a negative number, that's a problem. You get something that's not a real number. But you can do it with odd roots. For instance, -8 cubed is -8 times -8 times -8. 8 times 8 times 8 is 512, but these negatives don't cancel each other out. So I can take the odd root of a negative number. I can't take an even root of a negative number.
So that 9 should kind of tip you off that.
No, it's whether or not
729.
the evenness refers to the power of the radical, or the index of the radical. If this is even and that's negative, you're going to get NARN. If this is odd, this can be negative or positive, and it doesn't matter. You're still going to be able to do it. So you can always take the odd root of a negative number, but you can only take the even root of a positive number. Well, inside and outside makes a big difference, right? Because here you're taking the even root of a positive number, and we're able to do that. Here you're taking the even root of a negative number, and you can't do that. So, yeah, whether this is inside or outside makes a huge difference. Here, let me give you kind of a hybrid of that. What if I had, for example, negative of the sixth root of negative 729? It would still be NARN. Still not a real number. And by the way, don't write negative NARN. Just NARN is good enough. Okay? But yeah, these do not cancel each other out. So it would still be not a real number. Okay, last little tidbit for this section. And it's going to go back to, well, all right, we've seen a lot with roots. Sometimes we need to use NARN, sometimes we don't. Sometimes we had an absolute value. So the last part of this is, when do I need to use the absolute value? So that's a good question. And I kind of keep it restricted to what we're going to need in this class. I'm not going to answer it as generally as possible, but there's two cases that you're going to have to deal with. The nth root of x to the n. So if these two numbers match, like a square root and a square, or a cube root and a cube, etc., if these two numbers match, this is going to simplify just down to x if n is odd. Now, what are some examples of odd numbers? 3, 5, 7, 9, etc. So if n is odd, then the nth root and x to the n cancel each other out nice and evenly. The nth root of x to the n is the absolute value of x. What do you think has to be true to get the absolute value? Good. If n is even. So 2, 4, 6, 8, etc. So if n is even, then you need to use the absolute value. If n is odd, you just blow it off. You don't need the absolute value. Usually there's a good chunk of points that are awarded to this kind of a problem on your exam. Do you understand the difference here? So let me give us two problems to look at and try and simplify. So those two problems would be number 96 and 100. 96 is the fifth root of negative 32 x to the fifth, and 100 is the sixth root of 64, where is it? B to the sixth. Now, what I would suggest in both of these is that you break them up. And you can use your calculator to calculate the numerical parts. But the big thing I'm trying to see here is, do you understand which of these gets the absolute value? Or neither of them, or both of them. But try and look at this general rule to decide where you need the absolute value. Hopefully you got a copy down by now. Based on whether or not. Alright, yeah, we don't need it. What's that? Oh, that's the sixth root of 64b to the sixth power. Sixth root of 64b to the sixth power. Okay. So it's kind of cool at football games. There's a guy that steps out on the field. He's got a particular colored hat, and when his hand goes down, play can resume after a TV timeout. So, all right, our TV timeout is over. Let's take a look at these. Now, with the fifth root of negative 32, that's just negative 2. Fifth root of x to the fifth is x. Do I need the absolute value around the x? No. So we're good there. Negative 2x. Sixth root of 64. Again, that's a 2. I do not need the absolute value around that. It's just a number. The absolute value of 2 is 2, so even if you did write it, you could get rid of it. But how about the b? Do I need the absolute value around the b? Yes. So the only case in which you wouldn't need an absolute value around the b is if they told you ahead of time that you can assume b is positive. In that case, you could just dispense with the absolute value. Almost done. Let's do a nice follow-up to that one. Problem number 114. The sixth root of x plus 4 to the sixth power. Takers on that one? Dylan. Yeah, you can give me the answer too. There's a lot on the line. You can get this back. No pressure though. I was kidding about the no pressure stuff. Basically, I want you to decide, do you need the absolute value or no? Yes, you do need it. So it'd be the absolute value of x plus 4, period. So if this was like a 5, then I wouldn't need it. But because these match and they're even, then I need that one. So, cool. Thank you, sir. Problem number 116. The sixth root of negative 1. Not all at once. Anyone? Narn. Can't take the even root of a negative number. Yes? It's not really wrong, but I'm not happy about it either. We don't need the 2 in the absolute value. Yeah, then actually, that's the reason I split it up, is so that you can better see that we don't need the absolute value around the 2. Yeah.
Like number 102, can you explain why you don't need an absolute value if the numbers are both even?
Okay, good question. So it's something that my little thing here doesn't cover because the exponents here are the same. In problem number 102, which we avoided, and I would avoid problems like this on the exam, you've got the fourth root of x minus 7 to the 8th power. Now I gave you a little trick a little while ago as to how to simplify these things, right? You divide this exponent by this one. So we would get x minus 7 to the second power. Now, if you said, well, gee, that's even, I want to put an absolute value around it. Well, okay, but do I need the absolute values around a number like 7? Yeah, thank you. Do I need the absolute value around a 7? No, because it's already positive, right? Well, when you square something, that turns it into a positive number. So I don't need the absolute value around this any more than I need the absolute value around this. It's already positive. So I could dispense with the absolute value in a case like that. That was going to require a little bit more thought. And I kind of avoid that stuff. But it's a great question. You wouldn't need the absolute value around that one. $99 would be pretty much the same thing as this one. You've got the sixth root of k to the 12th, which, yeah, k12, which would be k squared. But again, you got something squared. Something squared is already positive, so I wouldn't need the absolute value around something that's already positive. So it'd just be k squared. Great questions. Great questions. So let me give you some homework. And let me give it to you this way. So for homework, try 23 through 121, but you can skip problem 49 and 59. Now do me a favor. Say stolat. Ready? Stolat. Stolat is happy birthday in Polish. Yeah. Dziękuję. All right. Stolat. All right. So, all right. Well, let me skip a couple more then. Let's skip 61 and 67. Stolat. Oh, Stolat. Okay. Well, let's skip 69 and 83. Stolar. Skip 85 and 95. All right. Skip 97 and 99. All right, there you go. One more time. Thank you very much. You can skip 101. All right. I think we're good for section 9.1. Nicely done.